Chapter 7 begins with techniques of integration, and it's the chapter opener on page 471. I know that you have an ebook and not a paper book, but it gives you important integrals that we've learned thus far, and you should know quite a few of these. So if we look at the next screen, I made them a little larger. I would make notes of them or screenshot them. For my purposes, these ones right here, we're going to see these the most often. And sorry about that. You get too close and it turns back. These are the ones we use the most often. This one sometimes, and this one. I'm not real big in the hyperbolic trigonometric functions. They have a place, but it's not something I'm going to put on a quiz or a test. So these are your quiz or test items. The rest of them you should be able to reference as you're doing your integrals. These are things you have to know. You have to just know them well. The first one right here is the power rule, and hopefully you're good with that. So section 7.1 begins with integration by parts. Consider f of x times g of x. Now you don't need to really make notes about this, but if we were to take the derivative of this, we use product rule. So we keep f of x, and we have the derivative g of x. So g prime of x. Plus, we take the derivative of f of x, and we have g of x. So that derivative has two terms because of the product rule. Now we know every derivative, you can take the antiderivative and go back to the original function. So we could say that f of x, g of x equals the integration of f of x, g prime of x plus f prime of x, g of x. So if we take the antiderivative of this long thing, we come back up with f times g. So we can split this. We have the integration of f of x, g prime of x, dx, plus the integration of f prime of x, gx, dx. And all we did is split the integral, so this still equals f of x, g of x. But that notation is going to be helpful in a minute. So it doesn't matter, let's keep one of them, f of x, g prime of x, dx, equals, let's move the other one to the other side, f of x, gx, minus the integration f prime of x, g of x, dx. Now this right here is our formula for integration by parts. It's the formula that's used, but we often use it in a different notation. We're going to let f represent u. So here we have u, and here we have u prime, and that comes in. And then we have du. And then we have v. So the way that we do this is we say that the integration of u dv equals uv minus the integration of v du. So you can see that here I have my u dv, and then we have u and v, and this is v and du. So it lines up. This right here is called integration by parts. This is the formula that you need to use. We find the pieces and we plug it in. And so it's used, it's the antiderivative of the product rule. It's going to look like a product rule. You just have to be careful that u sub is not what you're supposed to be using. U substitution is a very powerful tool, and if you can use it, you will. So I'm going to focus in this video on the fact that it's not u substitution and that it is integration by parts. So consider the problem. It says the integration of x sine of x dx. Now, in order to use integration by parts, let's start off with, could it be u sub? So, don't write this part down. If we let u equal x, which is the inside of sine, the composite function with sine, all we've done is change variables because du is dx. That doesn't help us any at all. So this is product rule. I have one function here and one function here. So we create kind of a box. UV and DU and DV. Now the more we do this, we'll see that whatever we put in U needs to eventually, the derivative needs to be a constant, because that's going to help us do away with our product rule. So think what has the derivative that's kind of going to go away. So in this case it's x, so this is our u, and then everything left will be dv. So we're going to say sine x dx. Now everything after the integration should be either in u or in dv. These two make up the entire problem that you are given. Everything has to go in there. Don't leave anything out. Now, let's take x. What's the derivative of x? So we're taking it over into here. So the derivative of u is du. The derivative of x is dx. That's super nice. That means you probably did it well. And then we have dv, so we're trying to go backwards to v. That's the antiderivative. So we're actually integrating sine of x. The integration of sine of x is negative cosine of x. Now we don't have to write a plus c, because that goes at the very end of the problem. Every time you use this formula, write it down, because it'll help you learn it. So the integration of u dv equals uv minus the integration of v du. So now we plug in the pieces, and we're going to say the integration of x sine x dx. Notice that's our u, and that's our dv. So uv, u is x, and v is negative cosine x, minus the integration of v, which is negative cosine x, and then du, which in this case is just dx. Now two negatives make a positive, so we're good. When we multiply x times negative cosine x, we get negative x cosine x, plus the integration of cosine x is sine x, and that's the end, so we say plus c. And that's our integration by parts. The key is to decide what this box right here holds. Lots of people set up this box lots of ways. I use UV and DU, DV. People set it up in different ways. If you have another way you like it, it will be okay. This is the way I'm going to set them up for me. So number 4 in your book on page 476, section 7.1, says the integration of y e to the 0.2 y dy. Now if we were to use u sub, we would let u equal 0.2 y and du equals 0.2 dy. Now that doesn't help us because there's another y in the problem. So u sub is not our method of choice. But we want to check it first every time. But I can kind of see the product rule happening here. Here I have one function, and here I have another function. They're not composite functions, where the one out front is kind of a multiple of the derivative. So we're going to say, set up the box. We have u, v, and du, and dv. So u is going to be what the derivative is going to be nice and easy and go away. So u is y, and go ahead and fill in dv. Don't get excited. dv is e to the 0.2 y dy. Everything left, everything in the integral should be in one of those two spots. Now the derivative of y is easy, it's dy. But the integral of e to the 0.2 y is not so easy. So let's look at it. We're going to let u equal 0.2 y. This is u sub. So du is 0.2 dy. So dy equals 1 over 0.2 du. So we have the integration of e to the u times 1 over 0.2 du. By the way, 1 over 0.2 is 5. So this equals 5 times the integration of e to the u du. And the integration of e to the u is e to the u. So this gives us 5, this gives us 5 e to the u, which is 5 e to the 0.2 y. Now that's important. We're going to come back to that. So we put that back up here in v. We're moving back up here. So v equals 5 e to the 0.2 y. My space might not be big enough, but I'm going to try. So now we say the integration of u dv equals uv minus the integration of v du. Take a minute, pause the video, and read it out loud twice. Maybe I'm going to read it again, read it with me, and then say it out loud twice. It will truly help you. So the integration of u dv equals uv minus the integration of v du. So we say the integration of y, e to the 0.2 y, dy. Some of you feel like this is a waste of time right there. It's a necessary skill because it might come in handy later. So let's keep going. It says u, which is y, times v, which is 5 e to the 0.2 y, minus the integration of v, which is 5 e to the 0.2 y, du, which is dy. Now I'm going to pull this 5 right here out front. So we're going to say, let's rearrange this, 5y e to the 0.2 y minus 5 integration e to the 0.2 y dy. Now some of you see this already, but this integration right here is the same integration right here, and this is the answer. So we can plug that in. We're going to say 5y e to the 0.2 y minus 5 times, and that integral gives us 5e to the 0.2 y plus c. So we have 5y e to the 0.2 y minus 25e to the 0.2 y plus c. And that's our answer. Now what's really cool is you could check it. Students are always impressed by the check. So let me see if I can remember that answer. So this is our answer that we came up with over there. So if we take the derivative of 5y e to the 0.2 y minus 25 e to the 0.2 y plus c, we should end up with the original function. So let's take the derivative. The derivative of 5y is 5, product rule, and we keep the e to the 0.2 y, plus we keep the 5y, and the derivative of e to the 0.2 y is e to the 0.2 y, and the derivative of 0.2 y is 0.2, chain rule. I know that some of you forgot your Calc 1. It's not allowed. You got to remember it. 25, the derivative of 25e to the 0.2 y is 25e to the 0.2 y, and the derivative of the 0.2 y is 0.2 plus c. Now 0.2 is the same as 1/5. So here I have 5e to the 0.2 y plus 1/5 times 5 makes 1, so I have e to the y, e to the 0.2 y, minus 25 times 0.2 is 25 times 1/5, which is 5, e to the 0.2 y. Oh, and the derivative of a constant is 0, plus 0. These terms cancel, and we're left with y e to the 0.2 y. See? So if you integrate that, if you integrate this, you end back up with this. Antiderivatives. It's really cool to see the check happen. The next problem we look at is the integration of the natural log of x dx. Students often want to tell me this answer is 1 over x. It's not. It's the other way around. The integration of 1 over x is natural log of x. The integration of natural log of x can only be done using integration by parts. So let's go ahead and set this up. And so we have u, v, du, and dv. Now, since we don't know the integration of natural log, we're going to put it in u because we know the derivative, but not the antiderivative. So that means the only thing left is dx goes in dv. So the derivative of natural log of x is 1 over x, so that's du, and that's with respect to x, so dx. And then the antiderivative of dx, there's an understood 1 here, so the antiderivative is just x. So we have the integration of u dv equals uv minus the integration of v du. Write it every time you use it. So we have the integration of natural log of x dx. Some people feel like that's a waste of time, but there is a technique where that's necessary. So if you're in the habit, it'll be easier to see it when you need it. So u is natural log of x, and we're multiplying that by x, which is v, minus the integration of v is x, and du is 1 over x dx. So we're multiplying these. So we have x natural log of x. Remember your properties of logarithms. That is not natural log of x squared. It's x natural log of x minus, now these cancel, so we really have the integration of 1 dx. So we have x natural log of x minus the integration of 1 is just x plus c. There are people who like to memorize the antiderivative of natural log of x, but it's really not that difficult to come up with. So it's just something you need to work through when you see it. So let's look at number 10 in your book. It says the integration of natural log of the square root of x dx. So let's make a note that the square root of x is x to the 1/2 power. U sub is not going to work because the derivative of x to the 1/2 power is 1/2 x to the minus 1/2 power. But that's always something you should check, because if you can use u sub, you want to. It's your best method. But natural log always goes in u. So let's call this x to the 1/2 because we have to take the derivative. And then dv is dx. Don't get excited about finding du and forget to fill in all of your u and your dv, because remember, this is where we start, is at u and dv. So to find the derivative of natural log of the square root of x, that's chain rule. The derivative of natural log of x is 1 over x. But here you have a composite function. So however chain rule works better for you, take a minute and find that derivative. So we have the derivative of natural log of something. And the derivative of natural log of something is 1 over the something. So we have 1 over x to the 1/2. It's a really bad looking 1/2. You have to remember that it's a 1/2. Times the derivative of x to the 1/2 is 1/2 x to the minus 1/2. Now when I multiply these, 1/2, oh, I forgot my dx. So when we multiply these, we get 1/2, and this is 1 over x to the 1/2 times 1 over x to the 1/2 dx. Now when you multiply, remember that we add exponents. So x to the 1/2 times x to the 1/2 is x to the 1/2 plus 1/2, which is x to the first. So we just have a 2x here, and then there's a dx. It's a pretty nice little du. We thought it was going to be all messy. And then the antiderivative of dx is just x. So we have the integration of u dv equals uv minus the integration of v du. So we have the integration of natural log the square root of x dx equals u, which is natural log square root of x, times v, which is x, minus the integration of v times du, which came out to be 1 over 2x dx. Again, these x's cancel. So we have x, ln square root of x, minus 1/2 times the integration of dx. Remember, there's an understood 1 in there. You could leave the 1/2 inside if you'd like. It's the same thing either way. So we have x, natural log square root of x, minus 1/2 x plus c. So let's look at one more before we end this video. Number 15 says natural log of the integration of the natural log of x quantity squared dx. So we kind of think u sub, where we let u be natural log of x, but then du is 1 over x, and that's not going to cancel out. You never want to put a variable in when you're doing u sub. So let's go ahead and set up our integration by parts. And here we have natural log of x squared. Remember, a natural log always goes in u. And then the leftover is just dx. I'm going to go ahead and do the antiderivative to be x. That's easy. Now here we have chain rule again. We have natural log of x as the quantity squared. So think of it as something squared. So we have 2 of these to the first times the derivative of the insides, the derivative of natural log of x is 1 over x dx. So we have the integration of u dv equals uv minus the integration of v du. So we have the integration of natural log of x squared dx equals u, which is natural log of x squared, times v, which is x, minus the integration of v, which is x, times du, which is 2 natural log of x, times 1 over x dx. So these x's cancel. So we have x, natural log of x quantity squared, minus 2 integration natural log of x dx. Well, now you're going to have to use integration by parts again, because here we have the integration of the natural log of x, and we just learned that that means integration by parts. So we're going to say u v du dv, and natural log of x always goes here, so this is dx. The derivative of natural log of x is 1 over x dx, and the integration of dx is x. So you always start at the left and bring everything down. Don't use bad math. So we're bringing all of this down, minus 2 bracket. Now here we're going to do integration by parts. So we have u, natural log of x, times v, x, minus the integration of v, which is x, times du, which is 1 over x dx. Now are we at the point where we can say this is the number 1 and go ahead and integrate? So this equals x. Always start on the left. Don't be lazy. That's a squared minus, let's distribute that. Let's distribute the 2 last. So here we have x ln of x minus the integration of 1 is x. And then we're going to say plus c at the end. Some people want to put that 2 in there, and then 2 times c is still c, because 2 times a constant is a constant. But the rules change a little bit when you get to differential equations, so let's put that plus c at the end. So we have x ln of x quantity squared minus 2x ln x minus 2x, but that becomes a plus 2x plus c. And that would be the answer to that problem. So sometimes we see that we're going to have to do integration by parts twice. Let's look at another one of those. Number 8 is the integration of t squared sine beta t dt. Now remember, you want your u to eventually go away. So we're going to let u be t squared, and you're going to see that we're going to have stuff left. And then dv is what's left over, so it's sine beta t dt. So the derivative of t squared is 2t dt. Remember, your t's should have a tail, so they don't look like pluses. And then to do this, we're going to say sine of beta t dt, and the antiderivative is u sub. So we let u equal bt, So du equals beta dt. So dt equals 1 over beta times du. So we have the 1 over beta times the integration of sine u du. I think I skipped a step there, but this video only has 5 minutes, and I'm a little worried about it. And this equals 1 over beta, and the antiderivative of sine is negative cosine of u plus c. So we have negative 1 over beta cosine of beta t. So negative 1 over beta cosine of beta t. All right, so we've got the integration of u dv equals uv minus the integration of v du. So we're going to say the integration of t squared sine beta t dt equals u, which is t squared, times v, which is negative 1 over beta cosine of beta t, minus the integration of v, which is negative 1 over beta cosine of beta t, times, let's put parentheses here, it can be around the beta as well, times du, which is 2t dt. Because that 2t doesn't go into the cosine, so be careful about that. Let's clean it up a little bit. We have negative 1 over beta t squared cosine of beta t plus 1 over beta integration of 2t cosine of beta t dt. Do you see why we still have integration by parts? Again, we have two functions being multiplied here. We have the 2t and we have the cosine of beta t. So we're going to have to use integration by parts again. So we're going to let u, v, du, dv, very small. U is 2t, and dv is cosine of beta t, dt. du is 2 dt, nicely. And we're going to integrate cosine of beta t, dt. So we let u equal beta t, and du equals beta dt. So dt equals 1 over beta times du. So we have 1 over beta, beta, the integration of cosine of u du. I kind of rearranged and moved things around, so pause and think about it. Equals 1 over beta, and the integration of cosine is sine u. So we have 1 over beta sine beta t. 1 over beta sine beta t. So that means we can move back into our integral. So this is going to now come down here, and we say equals negative 1 over beta t squared cosine of beta t plus 1 over beta, parentheses. We have uv, so u is 2t, times 1 over beta sine beta t, minus the integration of v, which is 1 over beta sine beta t, times du, which is 2 dt. So we have negative 1 over beta t squared cosine of beta t plus 1 over beta. And here we have 2 over beta t sine beta t minus, let's pull out the 2 over beta, and we have the integration of sine beta t dt. Now we did that back on the other side of the screen over here, so we can plug that in, and we have negative 1 over beta t squared cosine of beta t. Now I'm going to distribute this 1 over beta, so I have plus 2 over beta squared t sine beta t. Now I have minus 2 over beta, and I'm multiplying it by the box over here, negative 1 over beta. So this becomes plus 2 over beta squared times this beta to the third, and the integration becomes cosine of beta t plus c. Thank you.